In our welcome class this evening, we have a question that says an oil drum is cut in half. One half is used as a water trough, as shown below. Find the volume of the water in cm3. Now we notice that this is the oil drum, and it has the shape of what? A cylinder. Now to get the volume of this, you have to divide the volume of cylinder by 2. Now we move to this side to solve this problem. Now we have that volume of the trough, which is the volume of cylinder, equals volume of cylinder divided by what? 2. So we have been given all the parameters, which is pi r square over 2, and pi is given as 3.1 times the radius of this is what? 56 divided by 2, which is 28, times 28 times what? 82. Or let's move to, let's increase this a bit. We have 3.1 times 28 times 28 times 82 being the height all over 2. Now, we notice here that 2 can divide any of this to give us 14. Remember also that this is in cm3. Now, we have 3.1 times 14 times 28 times 82, all in cm3. So when you now multiply through, you're going to have something like 99646
Uncle.
cm3.
Uncle.
Yes.
Okay, I thought that the...
So when you approximate to the nearest cm, or maybe to the nearest 1,000, you're going to have something like 100,000 cm3. And if you approximate, take it to liters to give you 100 liters. Now remember that when we discuss about pyramids, we say that a pyramid don't have a cross-sectional, a constant cross-section. Rather, it has a vertex and what? A base, basically a base shape like the cross-section of the base. Either any of the plane shapes, be circle, be sort, or any quadrilateral, as case may be. Now, look at the example of the pyramid. This can be a pyramid.
That blue house skip I did.
This is a pyramid. You can have something like this. Or something like this can be a pyramid. Now, this is an example of a pyramid.
Uncle.
Now, a pyramid has a what? A vertex. This is the sharp point, sharp end point. We call that a vertex, and this is a cross-sectional area. Cross-sectional area. This is the, now, and let us check this. This center from this point up. This is what we call the height. If in this place, if you check here also from this center to this point, which is perpendicular to this. Remember, it's perpendicular to the radius. This is also the what? The height. Now, all pyramids have same method of finding their volumes. Based on their cross section, that is which shape, plane shape, form the base. Now, volume of a pyramid is giving us 1/3 cross-sectional area times the height. The volume of a pyramid is giving us 1/3 times the cross-sectional area times the height. In this second pyramid, assuming that this base, the length of this is just a square, so this is not what we call a square base what? Square base pyramid. This is a square base pyramid if this is it. And for this case, this is a circular base pyramid. Say circular base pyramid also. Circular base pyramid. So this circular base pyramid is what we call the cone. The circular base pyramid is what we call the what? The cone. Now, if you want to now consider their volumes, volume if it is a cone, we now have that what? 1/3. The base area is what? A circle. And the area of a circle is what? Pi r squared times the height. This gives us the volume of what? The volume of a cone. Now, if you are considering a square base pyramid, the volume of a square base pyramid will now give us 1/3 L what? Square times height. This is for what? Square base pyramid. Even if it is not a square base pyramid, if there is anything like the rectangular base pyramid, this will not be L times height. L times what? The breadth times what? The height. That will be that for that case. Okay. I say, what do you mean by a net? When you open up a cone, like opening up this one, the thing that make up the two-dimensional shape you can get from a cone is that part of a circle we call the sector. Look at it here. But this is a sector. This is a sector, and this is what? A circle. Now you say this is sector. This is what? Circle. We are talking about surface areas now. Now, in a cone, we have what we call the curved surface area, the CSA, the curved surface area, and what? The total surface area. The curved surface area talks about this area, which is this. See the curved surface, this thing, as you fold it, if you fold this thing now, we see now, this is the what? The area of the curved surface. That's this is the what? Curved what? Surface. In this curved surface now,
Uncle,
the circular base is not part of it. This is just the curved surface of this cone. And now the curved surface is same thing as what? Having the what? The sector of what? A circle. We say that so the sector of the circle forms the curved surface area of what? Of the cone. Now, in generalizing this, the formula for the curved surface, let us now come. You notice that here, look at this now. There are some things written inside this. The length of a cone, that's the slant length of a cone. Look at it here. It is this radius, just like the radius of the sector. When you fold it, the radius of this sector, when you fold it this way, you see that what? R is what? The slant length of the cone. Now, the length of this arc, see, this is an arc now. It comes and forms a circular base. That's the circumference of this one. It forms the circumference of this. So which means that what? It will have a separate what? Radius. See the separate radius of this one. So which means that what? The radius of this becomes another. Now, we have the radius of this, which is totally different from the radius that later became the what? The slant length. Now, we also know that what? Length of arc is equal to what? Theta over 360 times 2 pi r. You notice this one? Now, this is it. And also, we also note that what? The area of what? Let's just continue. We said here, note that the length of arc became the circumference of what? Of the circular base, which means that what? This r becomes L, and we have that the circumference of the circular base is 2 pi r equal to the length of arc, theta over 360 times 2 pi L. Note what is happening here. If you take away this one, and take away this one, see when you divide both sides by 2 pi, we have what? That's r will now give us theta L over 360. Note that theta L over 360. Now let us leave this case. Note what we have here. Now we are now going to get the curved surface area of this shape. To get the CSA, now the CSA, you see, remember that we said that the curved surface area is similar to the area of this sector, of this, and this is a sector. Remember, this is a sector of what? A circle. So this sector of a circle forms the curved surface, which means that the area of this sector is same thing as the area of the curved surface. Now, we now have here that curved surface area, CS, is equal to area of what? Sector. And now, what is the area of a sector? What is the area of a sector? Area of a sector is given as theta over 360 times 360 degrees times pi r squared. And remember that what the arrow we are talking about is the big R. This big R is also the length. That is theta over 360 times pi L squared. Do you understand?
Yes.
Now, let us separate these things. Theta over 360 times pi times L times L. This is same thing as, okay, to minimize space, let's just take this to this side. L times pi. Now, we note this thing. Taking note of that particular one, we have it here, which means that the whole of this is something as R times pi times L, which means that CSA of a cone is something as pi R L. So take note of this formula. Surface area. We add the words pi r, that's the base circle, the CSA plus what? Area of circular base. So, which is pi r L plus pi r squared. So this is the TSA of a cone. TSA of a cone is given as this. That's how to generate. Here is a what? Complete what? Shape, complete pyramid. Now this is a cut out or cut off region. Now this is what we call the frustum. Now we now have this case. You have examples of them as your reading lamp. Most of the West baskets have what? A shape of a frustum. Some cups have what? Shape of what? A frustum. And even our buckets have the shape of what? A frustum. So when we are asked to calculate what? The volume of a frustum, we know that what? It is the volume of the complete pyramid minus what? The cut off pyramid. Now, remember that the cut off pyramid has what? Has its own height. This has its own small height. Why this height of this first start from here to the down part. Now, as we all know that this has its own cross section, the smaller one has its own cross section, while the bigger one has what? The also cross section, that's the base cross section. Now we now have that the volume of what? A frustum. Volume of this frustum is equal to the volume of what? Big pyramid minus what? The volume of smaller pyramid. Volume of what? This is a big one minus what? Small pyramid, the small one. So this gives us the volume of what? The pyramid. And we note that what? Pyramids for all frustum, we have that volume of the first one will be the cross section 1/3 cross sectional area times the height minus 1/3 cross sectional area small a times height. One thing is constant, which is 1/3 capital AH minus small AH. So this gives us the volume of what? The frustum in general. When you want to calculate the volume of a frustum in general, this is the formula you are going to use. Now, let us now look into a specific frustum which we have been dealing with, the frustum of a cone. Here, in this case, A is what? Base area. The same thing with small a, and height is what? This one is base area of the bigger one, base area of the what? Smaller one. Base areas, why this one is what? Height of smaller and bigger. So smaller and bigger, smaller and bigger. So take note of these things. Frustum of a cone. This is a frustum of a cone. If you look at this now, notice that what? This is the cut out region, and this is the frustum. It's just an example as what the buckets we use in bathing, our lampshade or reading lamps. Now, using this formula, as we have stated before, using this, we notice that what? The cross-sectional area is what? Of the bigger one is a circle, and the height is this one. The cross-sectional area of the smaller one is also a circle with a height. So this boils down to say that the volume of the frustum of a cone is equal to 1/3 pi r square height minus pi r square height. So pi is common. You can bring out your pi. It will be pi/3, or let us write it off. Let's write it off. Now it will give us something like here. V will now be pi/3. Now we have what? R square h minus R square small h. So this is the volume of the frustum of a cone. Volume of the frustum of a cone is given as that. When the height of the frustum is given, maybe the height of a frustum is given, but consider the frustum. Now, this is a bigger R, this is smaller R. Now, the height of this frustum has been given. We now have that the volume of this frustum will be equal to 1/3 pi h r cubed minus r small r cubed all over r big R minus small r. We say 1/3 pi h bracket r cubed big R cubed minus small r cubed all over big R minus small r. Or it can be given as 1/3 pi h big R squared plus small r or big R small r plus small r squared. That is when you simplify it. So this is also the volume of what? The frustum of a cone. So these three formulas can give us say values. But one specific thing about this one is that the height of the frustum has been given with the other radius given, the radii this side and this given. But in this case, you may not know the height of the what? Frustum. You may know the height of the smaller cone and also the height of the bigger cone. You use this formula. Most times you'll be asked to get the radius of this. There's what we call similar triangles. The topic on similar triangles, use that issue of similarity to get their what corresponding radius and height, as case may be. There are prisms. Example of a prism. Now, a prism has what? A constant cross section. Now, on the cylinder, we have something like on a prism, you can have something like this. Whatever the shape could be, it continues to remain like that. So, now, one thing you need to note on prisms prisms is that the cross section remains the same. The cross section remains the same all through the word shape. The cross section remains the same. If you have a particular shape down here, it continues to remain the same all through to the top of what? To the tip of that. But in pyramids, it doesn't obey such what law. Now, the same thing applies to this cylinder. This has a constant cross section. It's a circle here. Circular base. Now, the thing, one of the most things about a prison is that what the volume of a prison is giving us. The volume of a prison is giving us cross-sectional area that the height. Here is the cross-sectional area. Cross-sectional area, and here is what a height.
Oh, my sister, like I forgot
Even
to
if
chat.
you cut off what?
No.
Even if you
No,
cut
no,
off
safe.
a prison, cut it off, continue to give that same one prison, just as the height increases. Prisons have what? Constant cross section. Constant cross section and the what? Is the height. Once you cut off a prison, the height will reduce, but the cross section is still same. The volume of a prison is given as what? As the cross-sectional area times what? The height. It is also true we calculate what? Surface areas on this also. When you open up what? Just like when you open up a cuboid is a prison. A cube is a prison. When you open up a cuboid, what you see there is what? Rectangles. If you open up what? A cube, what you're going to see is what? All squares. So same thing applies. Now for this thing, a cylinder, when you open up a cylinder, as you are going to open up now, when you open up a cylinder, assuming that this is a solid cylinder, the solid cylinder is a cylinder that has circles at both ends. They are closed at both ends. Now, if you consider a cylinder as what, as our case study now, let us wipe up this. A cylinder as a case study. This is a cylinder. The length of a cylinder is what? A cylinder has a circular, two circles and what? And a rectangle. Now let's just turn this thing upside down. Let's turn it. If you turn this in this way, now in turning this thing now, the height of this cylinder is the breadth of this rectangle. And the circular base, that's the circumference of this is what? The circumference of this is what? The length of what? Of the rectangle. So when we now talk about the curved surface area, the curved surface area talks about the area of what? This rectangle. So the CSA of what? A cylinder is equal to the area of what? Rectangle. The CSA of a cylinder is equal to the area of what? Rectangle. And the area of a rectangle is length times breadth. And what is the length? 2 pi r. And what is the breadth? Height. So this is the what? The curved surface area of a cylinder. We now talk about the what? The total surface area. If it is a solid cylinder, it is closed at both ends. We now have this one, and this one, which means that so the TSA will give us so 2 pi r squared plus so 2 pi r h. This is for a solid cylinder, a cylinder that is closed at both ends. This is what will be the total surface area of that cylinder. Now, for volume of cylinder volumes, you notice that what? Volume of pyramid. Prism, sorry. Volume of prism is equal to the cross-sectional area times the height. And now, a cylinder being a prism, now have the volume of cylinder will be what? The cross-sectional area, which is the circle, area of a circle times the height. So remember that thought, the cylinder and the cone has same words, they have relationship. If this is for prism, the pyramid will be 1/3 of what this value. So that's by the way. Having taken note of all these formulas required to solve the given problems, let us just give ourselves some little work. Use the formulas which have been given to solve the questions that will be posted on this board shortly.
To do right.
Use the above formula to solve the following. Find the
Please, can you move your
the
camera?
the surface area and the volume. After
Hello.
that, you work on this.
Oh, thank you.
Nakadibo mmiri.
So please work on it. In our next class, our next video, we will show the solutions to these problems. They are quite challenging, and we believe that we can overcome them. Thank you for being part of today's class. God bless you.